Hi, welcome back to another quick tutorial, and today we're going to talk about virtual local area network. Okay, so that's virtual local area network. So from the term itself, it's not the actual physical local area network, but virtual local area network. Now you're going to understand that more as we go and discuss it. So this is the outline that we're going to discuss about virtual local area network. Define, explain the types of VLANs over the WAN, types of connections, establishing VLAN memberships, motivation, advantages, and disadvantages. So the term VLAN stands for Virtual Local Area Network. And it is a network that extends to remote locations beyond the geographical limits of a LAN by using cable or wireless telecommunication services. So VLAN can be roughly equated to a broadcast domain. And this is an example of a VLAN diagram. You have the IP address, the IP network, and then you have 81 access point 1, access point n, and so on and so forth. So this part here, you see here, there's VLAN 2, VLAN 3, 401, 501. So even though it would look like they belong in the same network, they can actually be segmented by, that's because of the virtual local area network. So basically, the devices that belongs to VLAN 2, even if they have the same IP address as that one of the VLAN 3, even if they have the same network address, say for example 192.168.3, that's something, and then this one is 3 dot, say 192.168.3.1, and then this computer that belongs to the other VLAN is 192.168.3.2. Okay, they wouldn't be able to communicate directly. They wouldn't be able to do that because they are separated by the virtual local area network. Same goes for this. Okay, so you're gonna perform, for you to understand this more, you're going to perform it in the laboratory. So in the image above, or in the image that you've just seen, each switch has two VLANs. On the first switch, VLAN A and VLAN B are sent through a single port to the router and through another port to the second switch. VLAN C and VLAN D are trunked from the second switch to the first switch and through the first switch to the router. Now this trunk, okay, the connection between the VLANs, this trunk can carry traffic from all four VLANs. Let's go back there. This one here. This trunk, this one here, this trunk carries. They are in the same. Physically, they look like they are in the same network. So that's what it means. Okay, they are connected to the same trunk. So as if they had four different physical ports connected to the switch. The VLANs can communicate with each other via a trunking connection between the two switches using the router. So through the router, okay, that's the only way that the VLANs can communicate with each other. Okay, VLANs over the WAN, or the wide area network. VLANs can be extended across the WAN, but after considering the following two facts. Since VLANs defined over the WAN will permit LAN broadcast traffic to consume expensive WAN bandwidth, this is generally not advised. However, if the WAN bandwidth is free for a particular organization like an electric utility with dark fiber installed and it's right of way, then extending VLANs over the WAN can be considered. We're gonna have some more examples so that you'd understand that more. So differences between traditional switched LAN and the VLANs. So VLANs work at layer 2 and layer 3. Remember, layer 2 and layer 3. So if you talk about layer 2, we are, what kind of address? That's the MAC address. But if it's layer 3, that's the IP address. Okay, so VLANs work at both layers, so it can forward and receive both informations from layer 2 and layer 3 of the OSI. So both MAC and IP address. So communication between VLANs is done by routers. So VLANs provide a method of controlling network broadcast. So these are the types of virtual LANs. The first one is layer 1 VLAN. So remember layer 1, that's the physical layer. Okay, it's also known as the port switching. It can be used to provide security and isolation. It does not allow user mobility. Next is layer 2 VLAN. LANs defined by a list of MAC addresses. It provides full user movement, and this clients and server always on the same LAN regardless of the location. And then the layer 3, it is also known as the virtual subnet. So this uses now the IP addresses, okay, in the layer 3 VLANs. And we have the connections, how they are connected. You have the trunk link, access link, and the hybrid link. Okay, so these are the following. These are the 3. The trunk link, all the devices connected to a trunk link, including workstations, must be VLAN aware. They should be they should be able to detect VLANs that are present in the network. So all frames on the trunk link must have a special header attached. Next is the access link. An access link connects a VLAN unaware. Okay, so it is unable to detect VLAN information device to port of a VLAN aware bridge. So all frames on access links must be implicitly tagged. It should be configured manually. Okay, in other words. Next is hybrid link. Hybrid link can have both tagged and untagged frames, but all the frames for a specific VLAN must be either tagged or untagged. So this is combination of the previous two, which is the access link, the trunk link. So that's, you have combination, and you have the hybrid link. So establishing VLAN memberships. The two common approaches to assigning VLAN membership are as follows. So static VLANs and dynamic VLANs. So from the term itself, static, so basically it's the administrator who tags or physically assigns the devices to a particular VLAN. And then, so this is how it would look like. So physically assign ports. Okay, it will be assigned to these switches. So this computer will be assigned to this port, and then this PC is assigned to this port, and so on and so forth. That is using the static VLAN. While on the other hand is the dynamic VLAN. So it's a more intelligent setup because automatically VLANs devices, depending on the setup or the configuration, that it would add devices for a particular VLAN. So this is the figure. So you have VLAN MAC, so it's going to be automatically, so MAC address checked in database. So if it's checked in the database, it will be added into this particular VLAN. So it was configured in the VLAN database. So next is motivation. In the legacy network means the older versions of the network. Users were assigned to networks based on geography and were limited by physical topologies and distances. Now VLANs can logically group networks so that the network location of users is no longer so tightly coupled to their physical location. Technologies able to implement VLANs are FDDI, or Fiber Distributed Data Interface, ADM, and Ethernet. So even if they don't belong in the same building or the same floor, they can be grouped with that particular VLAN. So that's how flexible a VLAN could be, and there are a lot of perks and advantages if you're going to set up your computers in the network and use the VLAN technology. So advantages. So first is information security. The VLAN provides enhanced network security, and VLAN can be used to enhance firewall functions and restrict network access for one or more users. So if those devices are the only ones that are added into that VLAN, so that's basically it. The others won't be able to access the network and communicate with the devices within that VLAN. Next is broadcast control. So since they won't broadcast data to other VLANs, it will be confined to that VLAN only. So there's broadcast control, and which means also that there's optimization of traffic in the network. Next is physical. Let's go back. Maybe we jump. I think that's broadcast. Okay. Next is physical layer transparency. So VLANs are transparent on the physical topology and medium over which the network is connected. So that is true. So reduced cost. Segmenting a large VLAN to smaller VLANs is cheaper than creating a routed network with routers, because normally routers costs are costlier than switches. So we can apply, because we can use VLAN in managed switches, which are basically cheaper compared to routers. So it would really save cost for a company that if they set their network using VLAN, or you can even make VLAN within the VLAN, okay, to make it more depends, which actually depends on the structure of the network, depends on the need also, okay, which also is dependent on the need of the company, the setup of the company. Work groups. A VLAN can be created to accommodate group of users who will be communicating among themselves at high volume and reducing the impact on other workstations. Since they are grouped, they are basically private group. Okay, so they can communicate with each among themselves. Okay, and even maximizing network output, because there's less traffic, because you don't need to broadcast. It's actually related to the controlled broadcast advantage of using VLAN. So ease of administration. Much of the cost associated with network additions or relocations can be saved through the use of VLANs. Workstations can be shifted from one work group or department to another without installing a new network cabling. That's very, very right. Even if they are physically separated, okay, they can still be grouped together because it depends on configuration of the VLAN. Leveraging existing investments. We can leverage existing hub investments by assigning each hub segment connected to a switch port to a VLAN. So all the stations that share a hub segment are assigned to the same VLAN. So if you have hubs, you can still maximize the performance of the network even if you have a hub, because you're just going to connect it to just a particular VLAN. So the hub will not anymore broadcast, because as you can remember, hubs are dumb devices, because they broadcast the signal even if it's not supposed to be sent to that particular part of the network. So this is now segmented. Traffic is now segmented to a particular VLAN. So you can still use the hub and assign it to a particular VLAN, and it won't harm the other VLANs. It won't affect the other VLANs. So flexible and scalable segmentation, we can also assign VLANs based on the application type and the amount of applications broadcasts. And disadvantage, yes, there's a bit of hard work that is uh, in terms of figuring out on how to implement it. So that's why its management is complex. Possible problems in interoperability, and VLAN cannot forward traffic to another VLAN because it has to use a router, so that from one VLAN, even if they are in the same network, they won't be able to communicate with each other, because that's the point. Okay, you privatize, or you segment the network with the VLAN. So for you to be able to put that back so that those computers can communicate with each other, you have to use a router, okay, between those VLAN. Okay, but if you don't need that, you don't need to, which is specifically the reason why you're trying to create the VLAN, is you want to segment, or you want to divide the network, okay, virtually. So if you don't want to do that, so don't use a VLAN, so that you won't have to purchase or install a router within that network. Okay, so before using VLAN, you should first identify if you really need to implement it. If not, don't use VLAN anymore. So that's all, folks. Thank you for your time. Have a nice day. Bye.